Hey guys, welcome back. So this week our main topic is simplifying rational expressions. So let me remind you just what even is an expression. That is just something maybe that looks like this. It's something that doesn't have an equal sign. So if all of a sudden I throw like equals 10, now you can solve for x and this would be a quadratic equation. But if I don't have that equal sign, this is just called an expression. So how can I simplify this? What can I do with this to make my life easier and to actually apply real life math to that? So before you ever really do anything applicable, you have to be able to break down mathematical expressions. And so being able to take something that looks kind of complicated and simplify it, break it down, is really like step one into being able to do pretty much anything important that involves math. So I think of this whole week, and actually we're really going to be doing this for several weeks here until the end of the school year. This is what I think of as just like classic math. Like everything we learn from here to the end of the year is kind of just like stuff you're always going to see in like college type stuff math. It's just embedded and ingrained kind of into everything. And so when I look at this topic in this chapter, it's just, in my head, it's just like really traditional math. Like when I think of math, this is what I think of. So anyways, with that, let's go ahead and get started. Before we know what to do with stuff like this, like what I wrote out here before, we have to be able to know how to factor this. It's really step one into being able to do anything else. So you may have forgotten a lot about factoring, and this is not a section in the book, factoring. It's technically you're supposed to remember all of it from Algebra 1. But just assuming that you have forgotten how to factor, I'm going to take this whole first day and just remind you how to factor. And just remind you of all the things you learned in Algebra 1, because if we can't do that, then we really can't move forward in Algebra 2. So when you look at this example I just wrote out, it should hopefully be obvious that both of these have an x, and so you can factor out an x. And so what would be left is just x plus 2. So if you factor that out, because it's a common factor in both of those terms, a way of checking is just if you were to distribute it back out, you would get x squared plus 2x, which matches what I have here at the start. So I'm going to just kind of refresh with you how to factor in a couple different ways, and then in the next video we'll actually be able to move on and do a little bit of Algebra 2 stuff. Okay, so the first type that you see a lot, and this is the one you want to check for first, every single time, no matter what, always check if you can factor out a GCF, which is the greatest common factor. And we've done part of this earlier in the year, but it's just been a little while. So when I look at the numbers 9 and 3, I know they both can be divided by 3. So I can definitely take out a 3 from everything, but I might also be able to take out a letter. And let's look at it. So here there's a y, and here I have 3 y's. That means I can take out just one y. I can't take out any more because this one only has 1. So if I were to try and take out 2, well, this one over here doesn't have 2. There's nothing, no more than 1 y to give. So my greatest common factor is going to be 3y. I can take out a 3y from both of these terms. And by the way, when I say take out, I technically mean divide. I can divide both of these by 3y, and in the parentheses, I'm going to write what I have left. So in the parentheses, I would have, for the first one would be 3, 9y divided by 3y, the y's cancel, and 9 divided by 3 is 3. And in the second term, the 3 divided by 3, that part cancels, and the x cubed, since I'm dividing it by a y, this would get knocked down to y squared. So what I would have left is plus xy squared. And again, a way of checking is just distribute this back out to both terms, and when I do that, I would get 9y plus 3xy cubed, which is exactly what I had started off with. So I know I have the right answer. So just by taking out a GCF, I have factored this, and my final answer is what I have boxed in red. Okay, now remember, I always want to look and see if I can go any further. Like, is there something like difference of squares, or is this a trinomial that I can do factoring on? Like, can I do anything else with what's left in the parentheses? And on this particular one, I cannot, so I'm done. I'm going to stop right there. Okay, so let's look at the second one. When I look at the numbers 6 and 8, I can definitely take out a 2 from both of those. They both can be divided by 2. And then I look at the letters. There's definitely an S in both of them. I don't know why I'm jumping to the S, but I just felt like it. So I'll write that down. And then if I look at the R's, I have 3 here and 1 here, so I can take out 1. It doesn't matter if you write 2RS or 2SR, it's the exact same thing. We do normally write the number at the beginning though, so it would just be kind of weird to write like R2S. It just seems weird. So we don't normally write it that way. Okay, so what would be left in the parentheses? If I did 6 divided by 2, then that part would be 3. R cubed divided by R gives me R squared, and the S's cancel out, so there is no more S. Okay, and then in the next one, that would just be 4, because the R and the S have been taken out already, so there's no letters left. And I'm done. So what I have boxed in is correct. If I want to distribute this back out to both things, I can check my answer. I'm not going to do it just to save some time, but I always at least do it in my head, just really quickly, just to make sure that it works. Okay, and let's look at the last one. It should be pretty obvious that I can take out a 3 from all of them, but I can also take out an X from all of them. But that's it. I can't take out a Y from all of them because this one here doesn't have a Y, and for the same reason I can't take out a Z because this one doesn't have a Z. So remember, whatever we take out has to come out of everything. And what would be left in parentheses is 1 for the first term. I think a misconception is if I take this, my first term, and I'm taking out 3x, so I'm dividing 3x. Some people are tempted to write 0. But remember, anything divided by itself is actually the number 1, not 0. All right, and then for the second term, I would have plus y, because everything else is canceled. And the last one would be minus z, because everything else is canceled. And that's it. That's my answer. So this right here boxed in is my final answer. All right, that's how you factor using a greatest common factor, and usually we just say GCF. So now I want you to pause the screen here and try all of these on your own. Normally I walk you through the ones that you try on your own. Since this is just factoring by GCF, I'm not going to walk you through them, so make sure that you actually do pause the video, and when you hit play, you're hitting play because you're ready to see the screen full of complete answers. So go ahead and pause it here, write these 3 down, give them a try on your own, and then hit play when you're ready to check. Alright, so check these over. And I want to talk about this one because we might need to go a little bit further with that. But before I do that, check them over. You can hit pause here now if you need time. And in a second, I'm going to start talking about what I have boxed in green. So pause it if you need to. Just take a second and check your answers. Okay, so I want to talk about the last one, what I have left in green. Because if you notice, in parentheses here, that is just a regular quadratic. And I might be able to factor that further. I'm not really sure yet. I need to still think it through. But that should have triggered in your mind that you might be able to factor just this part in red further. So, of course, I'm still going to have the 2x squared on the outside. But the part I have in red, I might be able to break down into 2 binomials. So remember, regular factoring is you look at that last number and you write down factors of it. So 1 times 8 and 2 times 4. And you see if any of those can be used to add to get to this middle number. So can I add any of these up to get to negative 4? So let's think about that. With 1 and 8, could I ever get to negative 4? No. With 2 and 4, could I ever get to negative 4? No, I cannot. So actually this one cannot be factored further because none of the factors of 8 can be used to get me to add up to negative 4. But that is a thought process that you should have had. When you recognize that you have a basic quadratic here, in that form of ax squared plus bx plus c, just double check and see if you can factor that into 2 binomials. That's going to be an important step to check. Okay, so with that, let's go ahead and move on to exactly what I was just talking about, which is factoring just basic trinomials. So as a review again, we always look at this number and we write factors that multiply to get to that, and then you choose the ones that add to get to that middle number. So let's do this first example. I need to write out the factors of 12. Now technically it's negative 12, so we will consider that in a second. But let me just get the numbers written down. 1 times 12, 2 times 6, and 3 times 4. Now, since it's negative 12, I know that each group of these, one of the numbers is negative. So maybe it's a negative 1 times positive 12. Maybe it's positive 1 times negative 12. I'm not really sure, and I'm not going to write down like all of those negative combinations because I'll know which one to choose based on whichever one will add up to get me positive 4. Okay, so when I look at 1 and 12, that one's never going to get me to 4, even if the 1 is negative or the 12 is negative. When I look at 2 and 6, if I make the 2 a negative, then when I add them, it would be 6 plus negative 2, which is 4. So that does work. That does work to add to get me to positive 4, and so I know that this is the factor I want to choose, and I need to make the 2 a negative. So here's how I write it out. Since it's x squared, I know I'm going to write x and x, and I know I needed the 2 to be a negative, so I'll write negative 2, and I needed the 6 to be positive, so I write positive 6. Okay, and that's my answer. Now, it doesn't matter if you were to flip-flop these, if you were to write it as like x plus 6 parentheses x minus 2, that's the exact same thing. Both terms are still being multiplied, so it doesn't matter what order you write it in. Okay, so that's how you factor trinomials. So let's do a few more just to make sure we get the hang of it. And this is like step 1 in all the problems that we do from here on out to the end of the year that I was talking about at the beginning that I think of as just like classic math. So it's really an important step. So these will be important ones that make sure you practice them as we're going through this video. All right, let's work on the second one. So I need to write down my factors of 16. So that'd be 1 times 16, 2 times 8, and 4 times 4. It is a positive 16, so all of these can either stay positive or both of them could be negative. Because remember, a negative times a negative is a positive. Okay, and I'm not going to write that out. I'll just know that when I'm looking to see which ones add up to get me to positive 10. And I'll just keep in mind that they can both be negative if that's necessary. So looking at these, 1 and 16 will never get me to 10. 2 and 8, if I add them together, if they're both positive, that will get me to 10. So that's going to be my factor. So write out your binomial. Since it's a squared, you're going to write a and a. And I'm doing a positive 2 and a positive 8. And that's it. I'm done. Keep in mind, if you're ever iffy or not sure that you did it right, you can always FOIL this back out and make sure that you've gotten the original problem. So if I FOIL this back out, a times a is a squared, and then I'd have plus 8a plus 2a plus 16. And then these like terms combine together to get me 10a, which matches exactly that original problem. So I would at least FOIL it out in your head. I know as you get older and as you keep doing more math and it gets easier, we kind of start dropping the habit of checking our work, which to be honest with you is fine as long as you're checking it in your head just really quickly. All right, let's do the last one. So I need to write out factors of negative 15. I'll just write them out for 15. So 1 times 15 and 3 times 5. And I'm going to choose the ones that add up to get me to negative 2. Now remember, this was technically a negative 15, so one of the numbers is going to be negative. And it's kind of obvious that I can use 3 and 5 to get me to negative 2, but the 5 is the one that has to be negative because 3 plus negative 5 is negative 2. So I have to make sure that I make the 5 negative. So when I write out my binomials, I'm going to put x and x. I'm going to make sure the 5 is negative and the 3 is positive. And I'm done. That's my final answer. Okay? All right, so I want you to pause the video and factor all 3 of these on your own, and when you are ready to check, hit play. Okay, so check over your answers here for factoring trinomials, and when you're ready to move on, go ahead and hit play. All right, so the last type that we're going to learn today before we start putting them all together is how do you factor trinomials if this is not just a basic x squared? So what does that look like? And it's not a whole lot different. Like we still want to come up with factors of negative 6 that multiply and that add to get me negative 1. The only difference is when I set up my binomials, normally we're used to writing x and x because when you multiply those you get x squared. But this time, when I multiply them, I want to get 2x squared. So how could I get that? What are factors of 2? Well, the only factors of 2 is 1 times 2. So that means that my binomials here, one of them must have been 2x. That way, when you FOIL this out and you multiply this, you're getting 2x squared and not just x squared. So that's the only difference is that I am going to be writing these to multiply together to make sure I'm matching that leading coefficient. All right, so now let's go ahead and write out my factors of -6. And I'll just write them out for 6. So that's 1 times 6 and 2 times 3. Okay, so it's not as simple now as just thinking through the ones that add to get me to -1, because if, like, okay, my first instinct honestly would just be to choose the 2 and the 3 and to make the 3 negative, because that way it adds up to be -1. But if I just put that wherever I want, now it's going to be really important that we do FOIL this back out and check. So if I FOIL this back out, that gets me 2x squared minus 6x plus 2x minus 6. And when I put together my common terms, my like terms there, that's a -4x, which does not match my original problem up here where this said -1x. So I have to think about the fact that this number here being a 2, when I multiply this out with this term, it's going to mess it up a little bit, make it bigger than we wanted. All right, so let's work backwards now and see how could I fix that? Well, let's just switch them. What if I put the -3 here and the +2 here? And let's see what that does. So FOIL it back out. 2x squared plus 4x minus 3x minus 6. And then if I put together my like terms, I am getting 2x squared plus x minus 6. So I'm really, really close to getting it correctly. I just needed that to be -x. Okay, so that doesn't mean that 2 and 3 won't work. It still might work, but I've only tried it with the 3 being the negative and the 2 being positive. What if I change that? What if I make the 3 be the one that's positive and the 2 be the one that's negative and see if it works there? And then if that doesn't work, I'm going to flip-flop them and put the +3 over here and change it. So let's try that. Let's FOIL it back out. So I'm still, of course, getting 2x squared minus 4x plus 3x minus 6. And lo and behold, these add up to give me -x. So this is 2x squared minus x minus 6, which matches my original. So I know that I factored it correctly using +3 and putting that with the 2x and using a -2 and putting that with the x. So really, when you have a leading coefficient, it's just a little bit of guess and check. You know that your options are limited. Like, I just erased it, but when I had that written, I only had, like, this choice or this choice. And I can change around with, like, which ones are negative and where they're placed. But it's not like it's an endless guess and check. You do have a list that you're working from. Okay, so that's my answer. And again, actually foiling it out and checking your answer is pretty much crucial here because that's how you actually do the problems. So we're going to make sure that you're going to want to make sure you're doing that. All right, let's do the next one. So, I'm just going to erase the page so I have more room. So let's just start always writing out my factors of 12. 1 times 12, of course, 2 times 6, and 3 times 4. Now, I forgot to mention this on part A, but I have mentioned this to you guys many times throughout the year, is usually when you're factoring ones with a leading coefficient other than 1, like we are in these examples, oftentimes what ends up being the numbers that work are the numbers closer together. Like 1 and 12 are pretty far spaced. 2 and 6 are not that far spaced, but they're further spaced apart than 3 and 4. 3 and 4 are pretty close together. 90% of the time, the ones that end up being your answer are the ones closer together. So just to make my guess and check go quicker, I always start using those. Okay, I have a little bit more guess and check on this one though, because of this 6x squared, I could get that by doing 6x times x, but I could also get that by doing 2x times 3x. So I kind of have like two sets of parentheses that I'm going to be guessing and checking with. All right, so now let's try and place these numbers in here. Let's do 3 and 4. I'm not even going to fill in positive or negative yet. I'm just going to see if I FOIL this out, I can ever add to get to 17. So we know this first is always going to get me 6x squared, so I almost can like stop checking that. Let's just check this one and this one. So when I do this one right here, 6 times 4 is 24, and 3 times x will give me 3. So with 24 and 3, I'll never be able to get to 17. So that's not going to work. So why don't right now I erase that and try switching it. So I'll put the 4 here and the 3 here, and let's refoil that. Again, I don't really need to keep checking that first one because that's just going to keep giving me 6x squared. What I need to check is this loop and this loop. So 6 times 3 gives me 18, and 4 times x is going to give me 4x. So 18x and 4x. 18 and 3 will never help me get to 17, which means 4 and 3 are not going to be the numbers in this parentheses. But before I cross it off, let's check if it works down here. All right, so check this foiling, this loop and this loop. So this first loop, 2x times 3 would give me 6, and then 4 times 3 gives me 12. Using the number 12 and 6, could I ever get to 17? No. So, again, before I just get rid of that, let's try switching it, and let's put the 4 here and the 3 here, and see what I can do with that. So if I FOIL this, that gives me 8, and this gives me 9. Well, 8 plus 9 does add to get me to 17. So I know I found a good combination. So I'm going to erase this top one because that didn't work. And I already found one that did work. And that was putting the 3 here and the 4 here. And I'm just putting in my plus signs to make it complete. But let's go ahead and write out. Let's actually check all of the foiling now. So the first one, 2x times 3x is 6x squared. 2x times 4 gives me 8x. 3x times 3x gives me 9x. And then 3 times 4, of course, gives me 12. And this looks great. When I add those together, I get 17x, which is exactly what the original problem was. And so I factored it. I found a good match of parentheses to put those numbers in. Now, if that didn't work, then all that means is you cross off this as a possibility and then move on to the next one. So I would have tried 2 and 6 in both sets of parentheses, the one where I had 6x and x and the one with 2x and 3x. So you just keep guessing and checking until I have a winning combination. And this one did work. Okay, so practice that before we put it all together. So pause the screen, factor these, hit play when you're ready to check. All right, here are my factors for these two problems, and when you're ready to move on and put everything all together, hit play. What I would recommend doing is if you want to just pause here and check my answers, you can FOIL this all back out in both problems and just make sure that it matches the originals over here. All right, so last thing we're going to do is put everything together because this is how you're really going to see it. It's never really going to be separated and say, like, do this one by GCF, do this one by regular factoring. You kind of just need to look at it and be able to know what is your game plan for factoring. Okay, so when I look at the first one, and like, really if you're someone that likes to have steps, then step 1 is always, always, always check for a GCF because that makes your life so much easier if you recognize it. So in this first one, I noticed they all have an x. So take an x out and let's see what we have left. So that would be x squared minus 7x plus 10. But the other thing I'm noticing is this is just a quadratic. So let's see if I can break that part down further into two groups. So factors of 10 would be 1 and 10 and 2 and 5. Will any of those add to get me to negative 7? Yeah, 2 and 5 will if they're both negative. And is it okay that they're both negative? Yes, it is, because a negative times a negative is a positive, so that still works to multiply to get me to positive 10. So I can break this down further by filling out the binomials like that. And that's going to be my final answer. You want to break things down as furthest as possible. Otherwise, you will get really hung up and you won't be able to complete the math once we start moving past the factoring stage. So make sure that if you have a regular quadratic like this left, you are recognizing that and you can break it down. Okay, so that's my final answer, what I have boxed in. And let's do the second one. So second one, I'm noticing I definitely have a GCF. They can both be divided by 9, but I can also take out a p to the 5th power of both of them. And so what would be left? Well, this one would be p squared, and 36 divided by 9 is 4, so then it would be minus 4, and I took out p to the 5th power, so there's nothing left there. And actually, hopefully you recognize this is a difference of squares. Remember difference of squares, the pattern for that is that can get broken down into two binomials where one of them you add and one of them you subtract, whatever it is that it was the square of. So that's how I'd break that down. Another way, which I think a lot of you liked thinking about it, is p squared minus 4 is the same thing as p squared plus 0p minus 4. So if you want to think about that as a quadratic, and you're thinking of factors of negative 4 that add to get me to 0, well, that would be 2 times negative 2. And so that's how I filled out those binomials. So this is the furthest possible expression that I can factor it. And so that would be my answer. Okay, let's do the last one. First glance is they can all be divided by 3. I'd probably just verify that on my calculator if I was unsure about the 72. But it does. You can definitely divide it by 3. So I'm going to do that. And I can also take out how many n's? It looks like 4 from everything. So what would be left? I'd have n squared minus 11n plus 72 divided by 3 is 24. So plus 24. Okay. And then when you look at just this part, this is a regular quadratic. So let's think of factors of 24. And I'm hoping I can find a pair that adds to get me to negative 11. So 1 times 24, 2 times 12, 3 times 8, and 4 times 6. All right, and then just kind of glancing at it, it's sticking out to me here that 3 and 8 is going to be our answer because if you add those together, you get to 11. Now, keep in mind I wanted to get negative 11, so I do need them both to be negative. Negative 3 minus 8 is negative 11. And that's okay because when you multiply negative 3 and negative 8, you get positive 24. So I'm getting a positive here when I'm multiplying, but I'm getting a negative here when I add them. And that's exactly what I want. So my final answer will be n minus 3 and n minus 8 in parentheses there. Oops. With that 3n to the 4th still on the outside here because I took out that GCF in step 1. Okay, and that's as far as I can go with that one. So last slide for today is I need you guys to pause, try on your own. This is going to be more like what you're going to be seeing in the next video and just the next several weeks is you're going to see expressions like this, and you need to be able to glance at it and factor it pretty quickly. So pause here, try it on your own, hit play when you're ready to check. All right, so check your answers here. The red is the first step I did, and then the green of each of them is my final answer after I furthered as much as I possibly can. And the only thing that would really count as right is what's written in green. So if you only did half of it, if you wrote what's written in red, it's not only going to not be right, but you will get stuck and you won't be able to go any further in math. So that's okay if for now you wrote what's in red and you didn't think about going on, but make sure that kind of from here on out you really do factor as much as possible, and that's why it says factor completely, because what we do in the next coming videos is going to require that you have it factored all the way in order to be able to do the next step. Okay, that's it for today, you guys. Really important factor review. Hopefully it was helpful and you feel pretty confident with factoring before moving on to tomorrow, and I will talk to you guys then. Have a good day.